All right. Thank you, everyone, for coming to the first session of the day. Today, we have Christopher Neugebauer, who is a pillar of the local Python community and the Python community globally, serial conference organizer, director of LinuxConf.au 2017, the impetus behind the North Bay Python Conference, and God only knows, many, many conferences to come. He's going to tell us about Python 3 for people who have not been paying attention. Please give him a warm welcome.
Thank you very much. Thank you. As Josh said, my name is Christopher Neugebauer. You can tweet me at the handle that is on the screen somewhere. Not mentioned in my biography is that I have been a fellow of the Python Software Foundation since 2013, mostly as a result of being an organizer of PyConAU for the previous 2 years. What that means is that I guess I hold a small amount of the copyright to the Python programming language, which makes me a foremost expert in being able to tell you everything that is correct about Python. Do not question me. So, today's talk is Python 3 for people who have not been paying attention. So, for those of you who have not been paying attention, there's been 2 major versions of Python that have been actively maintained for the best part of the last 9 years. They're not entirely the same language, but they're very, very, very similar. And it's never really been particularly clear which of the 2 major versions of Python out there that you should learn, or which you should use for new projects, or whether it's a good idea to bring your existing Python 2 code bases over to Python 3. And 9 years down the track, we're now at a point in time where I feel that the answer to that question is changing quite a bit. So Python 3, for those of you who don't know, is a language that is almost, but not quite entirely unlike Python 2. In many ways, it's better than Python 2, but for a very long time, it's been a language that's been difficult to adopt. And because it's difficult to adopt, people have tended not to adopt it. And so today we are going to talk about Python 3, the language. And we're going to do that primarily by answering a lot of questions about Python 3. And most of these questions are going to begin with the word why. For example, why does Python 3 exist at all? Why has it taken so long for people to start using it? Or why should I use Python 3? Or perhaps more importantly in your cases, why shouldn't you use Python 3? And the main thing that I hope you'll take away from this talk today, which I'm going to put up front here, is that Python 3 is probably ready to use in the vast majority of use cases, and it's probably a better language for you to use than Python 2 in most use cases. So let's begin. Why is Python 3 even a thing that exists? So Python 2.5, which was the last version of Python 2, or Python that was released without saying that Python 3 was going to be a thing in the future, it was the result of 17 years of uninterrupted progress for the language. New features got added to the language, and there had been one case in the entire development of Python where features had been taken away, and they were minor features, and I don't even remember what they were. In many cases, certain features were done wrong up front, many features were realized more than once in the language, and the old ways of doing things got consigned to the history books, but they stayed around in the language and documentation would remain valid and people would be able to do things in many different ways. Who's typed import this into their Python interpreter? Okay, so about half the people. There's about 20 different things that it tells you that are the truth, right things about Python programming when you type it into your interpreter. You can do it now if you've got a laptop. I'll continue, but you can do that and read it through. Here's one line of it, calling out a certain other language in particular and contrasting it, is that there should be one, and preferably only one, obvious way to do things. The organic development of Python 2 meant that there was more than one way to do many things. And more often than not, the obvious, or the older way to do things, was very much not the right way to do things. So here's an example. In Python 2, the original way of writing a class is this old class up here, and the new way to make a class is to extend object. If you were to take somebody who is new to Python 2 and explain to them why you needed to extend object all the time, you'd probably have great difficulty to it unless they were an experienced Java programmer or something like that. If you don't extend object, things subtly break. And it's hard to explain why until they experience them breaking. So this example here shows us creating a read-only property on a class. Old-style classes don't support more recent features in Python, including descriptors. So descriptors are the underlying feature that make read-only properties work on Python classes. And so if you want to make a read-only attribute, you can't do it with old-style classes. You can define a property on it, but then when you set something to it, it will override the property that you'd made, and things will subtly break, and you can't tell that things are subtly broken. Whereas with new style classes, you can't override things. In this case, the obvious way to do things, the way where you don't override object, is broken, and it's the wrong way to do things. Some syntax in Python 2 is really non-obvious and introduces subtle bugs that take a very long time to uncover. If you want to handle two types of exception, you might try this perfectly legal piece of syntax. So what happens here when I run this code? It should print oops, right? Should print oops. What happens is it lets zero division error through. That's unfortunate. The correct way to do this in Python 2 is to add brackets around the two types of exceptions that you have. That's non-obvious. Both of these are valid pieces of syntax. Only the version that is not obvious does the thing that you expect. Here's the code that's written in a much more understandable way. The bit after the comma is the exception that is caught of the type that is before the comma. You need the brackets to specify a list of exception types. I've dealt with this bug more than once. I've introduced this bug more than once. It's problematic. These days, as of Python 2.5, I think, you can use the as keyword instead of the comma. It makes a much more readable code. You can understand what that E is now. But it's still easy to get tripped up by the old syntax. It's perfectly valid Python 2. There's also a style guide for Python called PEP8. It explains how things should be named, and the standard library in Python 2 follows PEP8 absolutely perfectly. No, it does not. That is a module, which should all be lowercase, and that is a class. And then there are things where there's URL lib versus URL lib2. I could not explain to you what the difference in purpose of those things are. They provide completely different functionality. They do sort of related things. They should all be in the same module. They are not. I do not know why. And the biggest thing that Python 2 gets wrong is that ASCII text and raw binary data are exactly the same data type. If you forget to treat some of your text as Unicode text in Python 2, once you start dealing with internationalized data or, emojis, things will break. So doing that is an important thing. So here's what Python 3 does in a nutshell. It fixes syntax by removing old features that were broken. You no longer have to derive from objects because old-style classes no longer exist. It removes syntax and old features that were broken. For example, having the comma-separated list of exceptions without a bracket. And it rearranges the standard library so that everything follows the Python style guide. And most importantly, there is one data type for storing raw binary data, which looks like the old Python strings type. And there's one data type for storing text, which is the string type. Rather than just treating everything you find in files or everything you pull down from the internet as text, you have to actively turn it into text, even for 7-bit ASCII. And the main effect of this is that if your application handles any text, can display any text at all, it will handle internationalized text, it will handle emoji, which is really nice. And it does all these absolutely wonderful things at the expense of breaking backwards compatibility with Python 2. Python 3 cannot run all Python 2 code. Anthony Baxter, who was release manager for Python 3 at the time, gave a great keynote at linux.conf.au 2008. If you want to understand the optimism and the motivations behind doing all of this, you can dig up the code, dig up the video. It's online somewhere. And the Python team, the Python core development team at the time said that by 2013, we would be using Python 3 for everything. I'm just going to check my watch. Who here is actually using Python 3 for everything they do? Not everyone. So it's 2017. Why am I giving this talk about something that everybody is going to be using by 2013? So the problem with modern software development is that the language itself is rarely the only thing that people depend upon. There's also major libraries, there's frameworks, there's all manner of dependencies, and Python 2 lasting for a long time has increased this because people have not depended as much on the standard library. It's created somewhat of a chicken and egg scenario where libraries wouldn't port to Python 3 until developers wanted to use Python 3, and Python developers would not use Python 3 until the libraries they supported came along and provided Python 3 support. So Python 3 was first released in 2008, and for a few years it was never actually clear that people would use Python 3. It was quite slow, nobody was using it, nothing supported it, and people were actually holding out hope for Python 2.8 for a very, very long time. Python 2.7 was released in 2010 for context, and something funny happened. NumPy announced Python 3 support, complete Python 3 support, in about 2012. And once that happened, basically everyone in the scientific Python community started using Python 3 within like 2 years. Django helped to bring the web community over the next year. And by 2015, the barriers to people adopting Python 3 have gone away. And not only that, Python library developers have slowly been releasing things without Python 2 support. This is a graph that Microsoft did in 2015, and that blue line is the proportion of packages on the cheese shop that support Python 3, and that red line is the proportion of packages on Python, on the cheese shop that support Python 2 only. It's up around 70% as of about 2 years ago, and I believe that number has probably crossed over. You can read this article. I couldn't find a more recent graph to show you. But basically, most of the stuff out there supports Python 3. And the second thing that stopped people from adopting Python 3 was the discovery that there was a common subset of both languages that was almost a usable language. So the common subset is basically, the idea was that when Python 3 first came out, you would do machine translation of your code using a tool called 2to3 to bring your Python 2 code over to Python 3. This turned out, firstly, not to be particularly reliable and did not produce a good translation of most Python 2 code into Python 3. And it also created a massive maintenance burden, and so people basically stopped doing that. And it turned out that there was enough of Python 2 embedded in Python 3, there was enough of the good bits of Python 2 embedded in Python 3, that if you could just write code in that version, in that subset of Python 2, you could run it on both versions of Python. And that's proven to be much, much easier. But there were a bunch of things that were in the way in Python 3. So remember this thing where all strings are Unicode in Python 3, so everything can deal with internationalized text. The problem was you could not actually create a Unicode string literal in the same way in both versions of Python, up to Python version 3.2. They removed this U prefixed string from Python 3.0, which meant that the way to create a Unicode string in Python 2 is not a way that would work in Python 3, and therefore you could not run code that dealt with any text at all using the common subset. So it wasn't until Python 3.3 when they realized common subset is absolutely the way to go, and we're going to put this U back in, that you could start to write reasonable code in both Python 2 and Python 3. And that was 4 years after Python 3 happened. So waiting for Python 3 to get good was actually a good thing. the language got objectively better. Python 3 these days is actually faster, has better performance than Python 2. And it's allowed a small group of people who are working with the language to come up with best practices and figure out how the language needs to improve, which is actually a really quite important thing for Python, which is a quite opinionated language. So I've just asserted that most of the barriers posed by earlier versions of Python 3 have gone away. So let's look at why you should actually adopt Python 3. The first thing is that basically everything that you probably depend upon in your Python code supports Python 3 at this point. Python 3 Readiness is a website. You can Google for it. It tells you the status of the top 360 packages that are downloaded in the Cheese Shop and tells you about the support status for Python 3. And basically everything important works there. There's like 5% of packages have no Python 3 support at this point. Now, the last Python 2.7 release ever will happen in some point in 2020. PEP 404 says that. That number was chosen deliberately, by the way. There will be no Python 2.8. That is to say, no more active development from the Python, from the CPython community development will happen on Python 2. So your language is going to go away. And Python 3 is actually a better language now. It's had 10 years of active development on it at this point, and 7 years worth of those improvements to Python 3 have not hit Python 2. Early releases of Python 3 were slower than Python 2. A lot of things were rewritten, a lot of things regressed where they shouldn't have, but these days Python 3 performs much, much better than Python 2.7, and performance increases are being added all the time in Python 3. And Python 2 has been stagnant for a very long time. There haven't been new language features added. In the meantime, active work has been done on Python 2. It's objectively a much better language, and here's a quick rundown of features that I like and that I have used. For example, Python 3.5 introduces optional type hinting. You can specify the type of data that your functions will expect as arguments and return. This is a thing that's optional, but it helps you make better documented code and helps you do a whole class of tests automatically. I gave a talk on this at PyConAU in 2015. There's also a talk next door on it. You can go to that if you want to catch the end of it. Or you can just check out my talk. It's on YouTube. Yield from addresses an issue in generators in Python 2, which is that they become very, very inefficient if your generator yields stuff from a different generator, because when you have to go next on an iterator, it has to go all the way down a tree and then back up a tree every time, or a call stack every single time you want to yield something from a generator. There is now a keyword which says that this generator is now this generator, and it only needs to do one call into the iterator in order to make things happen. This is both much more efficient. Your call stacks are a lot shallower when you're doing this sort of shallow form of, or simple form of generator delegation. And it's also much, much easier to write. You don't have to do these for loops. You can just go yield from. For scientific coders, people who deal with linear algebra stuff a lot, there is a matrix multiplication operator. This is handy because the standard multiplication operator in Python has the forward multiplication and has reverse. So if you don't provide like something that can deal with b times a as opposed to a times b, it will just do the opposite for you. That's not particularly useful for matrices, and so there is a one-way non-commutative multiplication operator in Python 3.5, which is really, really useful if you're dealing with matrices and stuff like that. It makes your code much, much more concise and readable. Python 3.6 adds string literals that can directly invoke variable names. And this is much, much easier to use than building up a dictionary for formatting stuff and then applying that. It will just inspect the variables that are inside the local calling scope and will create that for you automatically. And you do that just by putting the F in front of your string. So that says, anytime I mention a variable, take in those variables. It's a thing that Perl and PHP people have had for a very, very long time. It makes dealing with text in those languages much, much easier than it's ever been in Python. This is great. And finally, there's now language level support for asynchronous programming. I wrote the slides after I delivered this talk, so I don't have them for you right now. I recommend Lee Symes's talk from Kiwi PyCon last year if you want to learn more. The content is really good and there's lots of cat pictures in it. So you want to try out Python 3 because it's a great language. If you're starting a new project, it's really, really easy. You can just go and write Python 3 code now. Everything you want to depend upon will depend upon it, and the language is great, and you should go and do it now. I'm doing it for all my new Greenfields projects. But if you have old code, the best way to move to Python 3 is to slowly make your code work on Python 3. Let's look at how you do that. The first thing you need to do is write all your code in the common subset. This means that your new code will run on Python 3 once the rest of your code can run on Python 3. At this point, your code probably can't run on Python 3, but you want your new code to be able to do that. You need to have excellent test coverage. And the reason why you do this is because you're probably going to be running your code in 2 different languages, and you need to make sure that the behavior doesn't change when you swap to a new language. You need to make sure that your code does exactly the same thing under both Python 2 and under Python 3. So you need to have at least 90%, if not more, test coverage wherever possible. You can run Python 2.6 and Python 2.7 in a thing called warnings mode. I think the command line flag is -3, and that says when you run under -3, you'll get a warning whenever your Python 2 code touches something that is not going to be present in Python 3, and it will probably also tell you how you can fix it. So you can tell your test runner to run with -3, and then when you run your test suite under Python 2.7, you'll get warnings everywhere you are doing something that presents a compatibility risk. It'll tell you when you're doing something that definitely will not work in Python 3. Now, remember how the standard library has changed and everything is in a different place in Python 2 versus Python 3? The library 6, which is available from the cheese shop, it bridges over those renames. So rather than directly using the standard library, you use 6, which provides you with the thing from where it is in the standard library if you're under Python 2, and it refers you to the standard library in Python 3 if you're in Python 3, and it does that all automatically for you. So it means that if you want to target both 2 and 3 using and you use the standard library at all, you need to use 6 or you need to do machine translation. I recommend using 6. You need to make sure that your dependencies will run on Python 3, and the py3readiness.org site will help you find all of that. Once your dependencies work, you need to make all of your code work. If you have good test coverage, then that should be relatively easy, if not tedious. If things work under test, then presumably things will also work in production. Hopefully that works all the time. Once you've made that move, you can abandon the common subset. You can start using actual Python 3 features. That's really, really exciting. I recommend looking at Instagram's keynote from PyCon US this year if you want to see about how a real-world website that people actually use has done this. They replaced their Python 2 code base and made it run on Python 3 without people noticing, which is really, really cool. Their talk goes into how they did that in practice. So let's leave here with a few minutes to talk about why you should not move to Python 3. Because if you have a Python 2 code base, you may well not want to move over. Because there is always a cost to porting. You will need to spend a significant amount of developer time on any significant code base bringing stuff over to Python 3. So that cost will almost certainly be a loss of productivity for a number of developers because someone will need to go and do that code. So Python 2, as I mentioned, goes end of life in 2020. That is a real problem. The core Python team will stop producing security updates. The language will stop being worked on. But there are big legacy code bases that still run on Python 2. And as long as people with money want Python 2 support, someone is going to keep it up and running. And we can even put a lower bound on that. There's a very large Linux distributor that you might have heard of who produces a commercially supported Linux distribution called Red Hat Enterprise Linux. You can guess who the company is. They provide a commitment that when they release a version of Red Hat Enterprise Linux, they will provide a 6-year commercial support cycle for anyone who pays for it, and that code will be open sourced. So even if RHEL dropped Python 2 at the very first opportunity in 2021, there is still a very recent release of RHEL that contains Python 2, which will get security support until 2024. So there will be somebody actively working on Python 2 providing security support until at least 2024. And if someone with money comes along and wants to pay Red Hat to develop it more, I suspect there will be more Python 2 development done by Red Hat beyond 2024. So you have not until 2020, but 2024 to move away from Python 2. So you don't have to be quite as urgent as you might have been, as long as you're using Red Hat or CentOS or something like that. So Python 2 will be around for a very, very long time, even though Python 3 is a better language and you should use it. So in conclusion, Python 3 is pretty great. You should consider using it. But as with any big tech change, you may find reasons not to. And you'll still have some level of support for Python 2 for the foreseeable future. And that is the end of my talk. I think I have a few moments for questions if you wish to ask one. Raise your hand and Josh will come around with a microphone. Yes, Paul.
G'day. One of the things that I think, when you were talking about Python 2 there not changing for a long time, my ears hear the word stability. So I'm wondering, do you feel like we're reaching a point where Python 3 is stable enough that a developer can start working on it now and not feel like they have to keep on adding, keep up with the latest features, or things are going to be deprecated?
Yeah, sure. So deprecation is not an issue with Python, because the reason why we moved to Python 3 was to break backwards compatibility. As long as the major version number stays constant, your features will remain in place. Python 3 is going to have more minor releases than Python 2 ever did. We're up to Python 3.6 now. Python 3.7 is happening soon. There are only 7 releases of 8 releases of the Python 2 branch. There will almost certainly be a Python 3.9, for example. I feel as though Python improves a lot more conservatively than certain other languages, and I think that Python 3 has been stable since Python 3.3, and it's been an excellent, objectively better language to use since Python 3.5. Python cares about your code working and being stable, and the core development team have people from all manner of important companies who care as much as you do about stability. So I feel confident. You should too. Yes?
Not a particularly pragmatic question, but sort of, if we knew what we know now back then, like if you could go in a time machine and talk to Guido and the team back when they were first going into Python 3, like what would we tell them, or what would we tell other languages looking to go for a big backwards compatibility change?
What will we tell the core team? Well, Python 3.3 was the first version of Python 3 where there was a feasible porting strategy. So having the library 6 and having the common subset were the 2 essential things that made all the libraries and dependencies that people have work on Python 3. So I think the first version of Python 3 would have looked like Python 3.3 as opposed to Python 3.0. And that would have been the right thing to do, and I don't think things would have moved nearly as slowly had we have had that. It took 4 years for that to happen after Python 3.0.
I think we have time for just one more question here. Yes.
So I guess the majority of this talk has been about CPython. Mm-hmm. What is the state, or do you know what the state is of Jython, Cython, the other sort of alternatives?
Jython is moving slowly, unfortunately. And it will continue to move slowly. I think it's got some level of early Python 3 support, and PyPy is getting better. I couldn't tell you the exact details at the moment, but it's relatively easily available. That said, Beware, which is a really, really cool alternative implementations of Python project, is targeting Java support because they want to deploy to Android, and they are staying with the bleeding edge of versions of Python. So whilst Jython is going away, there are other alternative implementations of Python that are actively supporting Python 3 and actively targeting Python 3 instead of Python 2.
I think that's all
we're
the time
definitely
we
out
have
of
for
time.
questions.
Okay, so thank you all very much for coming. I hope you learned some stuff. I'll be here or outside if you want to ask me some questions in the hallway.